Okay, this is the first part of lesson 4, exercise 4.1. It is paths. For the reading in your book, this is section 4, and it's pages 68 to 74 is relating specifically to this assignment. But you should read pages 61 through 74. That's roadways, which we'll discuss when I get back, and 70 to 74. That'll include roadways and paths, but specifically to this assignment, pages 68 to 74, which will help you work through them. What we've got here is we've got 3 pathways they're all 6 feet wide. They have the same elevation, starting elevation. They're going downhill from 50.2 this direction. You have a longitudinal slope of 4%, cross slope of 2%. This is only going one direction, right? This arrow for the cross slope. So this indicates that this is a concrete sidewalk, not an asphalt. We've talked about this earlier, but basically you've got 2 kinds of roads or paths. An asphalt is crowned in the middle, so the water would drain both directions, and this would be the center line right here, right? So it drains that way. A concrete road drains one direction. So this would be the edge of the road, this would be the edge of the road. Drains one direction. These are concrete because they're draining only one direction. To start, first thing we always need to do is find the nearest hole contour. It's going downhill this direction, so the nearest hole contour is going to be contour 50, which is 0.2 feet lower than 50.2, so we got to go 0.2 feet vertically at a 4% slope. So horizontal equals vertical divided by slope, and we said the vertical is 0.2, and we got to divide that by 0.04, which is the vertical distance from 50.2 down to 50, and the longitudinal slope 0.04. If you go 0.2 divided by 0.04 equals 5 feet. So this is an architect's scale. And if you turn to here, this is 6 feet. The way we know it's an architect's scale, it's 1 inch equals 12 feet. And if you look at this, you can see from here, there's 0, 3, 6 feet. Actually, it's right there. 6 feet. So we said it's 5 feet away, so just turn your scale, measure 5 feet right there. There's your first contour. That's contour 50. Next, we need to know, now we're going to drop a foot, right? We're going to drop, this is contour 50, so we've got to get to 49. We're going downhill. So it's, instead of 0.2 divided by 0.04, it's 1 foot. Now we're going 1 foot vertically divided by 0.04 or 4%, and that equals 1 divided by 0.04, 25. So every contour is 25, every 1 foot contour is 25 feet apart. This is 12 feet from here to here. We're going to go 12, 24, and another foot. So there's one contour right here. There's one. You put a little X there. X marks the spot. Another 25 feet. 24. Another foot, and there's your 25 feet. So little X is there, spot elevation. So it's contour 50, 49, 48. Now, because the cross slope is going one direction, we can't draw a slight guideline like this. Now the contour can't go straight across, right? Because there would be no slope for the cross slope. It wouldn't drain, right? Because the water goes perpendicular, so it's draining this way, perpendicular to these contours, right? So we've got to turn the contours at an angle, and we've got to turn them I'll draw it over here. We got to turn them, the water's going this way, so it's going downhill this way. The contours have to be at an angle. If this continued, they're at an angle so that your water is draining off the path this way. If you make your contours the other direction, this way, like this, and it's going downhill this way, then your water is going this way, so your cross slope would be going off the path that way. They're showing you that it's going this direction. It's showing it going straight this way. In reality, the water drains at an angle because it's going this direction and this direction. So it's sloping this way. I can't really show you. Sloping both directions, so it's coming off at an angle. Let me erase this. Next thing you need to know is length of deflection calculation. That's how you determine how far your contour goes, what angle to drain. So the calculation is pretty easy. It's 1/2 the path width. In this case, it's a 6-foot path, so it's 3 feet, half the path width, times the cross slope, which is 0.02 cross slope. That equals 3 times 0.02 equals 0.06, and then divide that by the path longitudinal slope, which is 0.04 longitudinal slope. So you go 0.06 divided by 0.04 equals 1.5 feet. So what that's telling you is that this line is going perpendicular to your path. It needs to go 1.5 feet on this end, this direction, downhill. This direction on this side of the path, it goes 1.5 feet this direction. So if we draw that, it looks like this. So we go 1.5 feet this way, 1.5 feet the other way. Connect those dots, and there's your contour. This is contour 50. And see, your water is going, right, always perpendicular, and it's downhill this way. So the water is going this way off your path, this direction. So your longitudinal slope is going this direction, longitudinal slope is that direction, your cross slope is going this direction. So then we just do the same exact thing, this 1.5 feet on each one, each of your contours, each of your spot elevations, and connect it. Boom. There's 49, and then 48. 48. So there you go. Contours are 25 feet apart. We've got a longitudinal slope of 4% that direction, and we've got a cross slope of 2% this direction. Continue that for these other two paths. They're the same width, they just have different longitudinal slopes and cross slopes, and we'll go over them when I get back.